In this video we are going to discuss about temperature effects. So I can write Tj minus Ta is equal to this proportionality constant into Pd. So I can write the Pd is proportional to Tj minus Ta, where Pd is a power dissipation which is usually represented in watts, and Tj is nothing but a temperature of collected base junction of the transistor, which is measured in degree Celsius, and Ta is nothing but ambient temperature of the air around the transistor, which is usually represented in degrees Celsius. The symbol represents the constant of proportionality, that is thermal resistance, usually represented in degree Celsius per watt, and it is in the range of 0 to 2 degree Celsius per watt. So for the power transistor, the total thermal resistance from the transistor junction to the case, for normal it is a total thermal resistance from transistor junction to the ambient temperature. So Pd so for the constant of proportionality, I can write it as Tj minus Tc divided by Pd. This is for power transistor, and for normal I can write Tj minus Ta divided by Pd. Okay. So I can write the constant of proportionality J minus A junction to the ambient temperature is equal to junction to the case plus case to the ambient temperature. So this value is already given by the manufacturer, and this constant of proportionality from case to ambient temperature. So if the surface area of the transistor increases, the case also get increases in order to reduce the heat flow. So the larger the heat sink, smaller will be the thermal resistance. So I can also write this formula as instead of Ca, I can write Ca in parallel with Hs of A. Usually the Hs of A is always greater than C of A, so this Hs of A get cancelled out. Otherwise you have to write Ca in parallel with Hs of A. So let us discuss one problem. For the given transistor, the thermal resistance is 8 degree C per watt, and for the ambient temperature is 27 degree C. If the transistor dissipate 3 watts of power, that is Pd is equal to 3 watt, calculate the junction temperature. Okay, so here E is missing. So this is the formula we know already. Tj minus Ta is equal to constant of proportionality into Pd. So they have given the value, they have asked Tj value, so you have to substitute Ta. What is Ta? Ta is 27, and constant of proportionality, that is thermal resistance, is 8, and power dissipation is 3. So 8 into 3 is 24. 24 plus 27 is 51 degree Celsius. So the junction temperature value is 51 degree C. So let us discuss another problem. So they have given constant of proportionality for Hsa is 8 degree Celsius per watt, and Ta is ambient temperature is 40 degree Celsius, and Tj is 160 degree Celsius, and J to C is 5 degrees Celsius per watt, and Ca is 85 degree Celsius per watt. So they are asking about the power dissipation with respect to the heat sink. So we know that Tj minus Ta is equal to thermal resistance into Pd, where I can write this J of A as J to C plus H of Hs of A in parallel with C of A. So they have already given the value Tj minus Ta. What is Tj? Tj is 160 and Ta is 40, so we will get 120. So we need Pd. So Pd is equal to 120 divided by this value. So J to C is 5 degree, and this parallel I can write it as if I take this is x and y, xy divided by x plus y. So I have to substitute the value of x. What is x? X is 8 and y is 85. So 8 into 85 divided by 8 plus 85. So you solve this two values, you will get one value, and you have to add this one. Then you divide 120 divided by this answer, you will get the power dissipation is equal to 9.75 watts. So basically this class A, this power amplifier is based on the value of how the power get delivered to the load. We need to calculate the maximum power dissipation, and also we need to calculate the temperature effects. So in the next video we will discuss about class B amplifier, which is also classified into two types. One is push-pull amplifier, and another one is complementary symmetry class B amplifiers. We will discuss about the efficiency and also the difference between the push-pull amplifiers and complementary amplifiers. So this topic basically they will ask in 2 mark question only. So I hope this video is useful for you. We will discuss the next topic in further videos. So thank you very much for listening to this video. Thank you.